Read this. In a projectile, the velocity is always perpendicular to the acceleration, never perpendicular to the acceleration, perpendicular to the acceleration for only one instant, perpendicular to the acceleration for one instant only, perpendicular to the acceleration for 2 instants. Very good. Now let us see this. Let us say this is my ground. Please all of you see here. This is the projectile which I have started. It went and came down here. Now please all of you see here. Initially I have projected it with an initial velocity u, making an angle theta with the horizontal. This is the total velocity. And how is my acceleration? How is my acceleration? It is acting vertically down. It is acting vertically down. Now what is the angle between velocity and acceleration? What is the angle between velocity and acceleration? Pi by 2 plus theta. Pi by 2 plus theta. Now take any position before maximum height. Now see, so if I split this, I have a velocity in this direction u cos theta and a velocity here u sin theta initially. Now anywhere in between, the horizontal velocity u cos theta is same. What about the vertical velocity? It's not u sin theta, but there is some velocity in vertical direction, some value. So because of that some value, the total velocity is not horizontal, it will turn like this, some angle. I don't know how much it will turn. This is the total velocity. What about the acceleration? Still it is vertically down. Now what is the angle between total velocity u and this acceleration? It is some angle pi by 2 plus some alpha. I don't know, this angle is some alpha. Less than theta definitely, but something greater than 90 degrees. Now come to the highest point. What is happening in the highest point? Horizontal velocity is still the same u cos theta. What about vertical direction? It is 0. As it is 0, so the total velocity is v. Now what happens to acceleration? Wherever you take, it is always g downwards. Now what is the angle between both? Now what's the angle between total velocity and acceleration? 90 degrees exactly, perpendicular. Both are perpendicular. So this is the first instant. Next, you take somewhere here. Still my horizontal velocity is u cos theta. This is same. What about the y direction? After highest point, as it goes down, it is gaining some velocity. It's not u sin theta, but it is having some velocity. Some velocity is there. Still some velocity is there. So what will happen to the resultant? It will be somewhere here. Came down by some angle, let us say some alpha. It has came down by some alpha. Now what happens to my acceleration? It is still g downwards. Now what will be the angle between them? 90 minus alpha. And the time it reaches the final point here, still the velocity in this direction is u cos theta, and vertically it has become u sin theta. By the time it hits the ground, it is u sin theta. The total velocity is u, making an angle theta with the horizontal. Now still my acceleration is g downwards. Now the total velocity, total acceleration. So what's the angle between both? 90 minus theta. So it is changing from pi by 2 plus theta, slowly decreasing to pi by 2 minus theta. So in the complete path for only one instant, it is getting 90 degrees. So perpendicular to the acceleration for one instant only. In projectile motion, the velocity is perpendicular to the acceleration for one instant only. I'll go for the next question. Two bullets are fired simultaneously horizontally and with different speeds from the same place. Two bullets are fired horizontally and with different speeds, not same speed, different speeds from the same place. Okay, which bullet will hit the ground first? Faster one, slower one, both will reach simultaneously, depends on the masses. See, what is that he told? Let us take somewhere from somewhere. Two bullets, let us say, or fine. Bullets. Let us say I have a gun. Let us say I have two guns at the same position. Let us say I have the two guns at the same position. Two guns are there. Two guns are there at the same position, same height. Okay, this is the ground, both are at the same height. Now what happened? Two bullets are fired simultaneously horizontally with different speeds. Fired simultaneously, so both are fired at the same time, not one before one after. Both are fired at the same time from the same place, but having horizontal velocity. Let us say blue one is A, red one is B, but both are starting from the same. Let us say the first bullet VA is having higher velocity than VB, but both are fired at the same time from same place horizontally. Remember my words carefully, horizontally. Now he is asking which bullet will hit the ground first. So please. Now I want the time taken by the bullet to reach the ground. Now both the bullets has to travel the same vertical distance h because they are fired from the same point. Now what is the velocity, initial velocity in y direction for the first bullet A? I have given all the velocity in horizontal direction, so in the vertical direction it is 0. What's the velocity in y direction for the bullet B? What's the initial velocity for y direction for the bullet B? What's the initial velocity in y direction for the bullet B? How much is that? All velocity is in horizontal direction, so in y direction it is going to be, in the vertical direction it is going to be 0. Initial velocity for both the bullets is same. Both has to travel the same height. Next, what is the acceleration? This and this both are pulled by earth. I told very clearly yesterday, whatever might be the mass, earth will pull them with g downwards. So the acceleration in y direction for bullet A is g downwards, and for bullet B also it is g downwards. Initial velocity is same, acceleration is same, distance is same, so obviously time will also be same. So both will reach at the same time. Is everybody okay with that? This is the question written by me only. A buffalo rancher. So what do we mean by this buffalo rancher? Because this word is invented by me. I am very weak at English, sir. So I have searched for these guys. I mean those guys who take care of buffaloes, cows and all these things. I have searched. They are just giving the word rancher for the guy who takes care of animals. So finally I didn't get a specific name for it, so I added here buffalo rancher. Throws a stone over a lake to make the buffaloes come out of the lake. What is this means? In front of my house in the village, I have a big, not a very big, a small, not lake I can say, a small pond. A small pond is there. Early days it used to be for drinking water, but now it is a swimming pool for buffaloes. So it's a swimming pool for buffaloes. So evening at 4:35 they will come straight, go to the swimming pool. They will go deep inside. Now they won't come out. So what to do? So these ranchers, these guys will be playing there for some time, and they will start collecting the stones and they will throw on them. Right? They will throw at some angle. So what's the path followed by that stone? Nothing but a projectile. So he is throwing a stone over the lake to make the buffaloes come out of it. Now the angle at which he should throw the stone, so that range of the stone will be maximum. So what's the formula first? Velocity is same, only he is asking at a given velocity what should be the angle so that it will be maximum. So what's the formula? Range R is equal to u square sine 2 alpha by g. Please all of you see here. Velocity is constant, g is constant. Those are given by me. For range to be maximum, what should be the angle? So sine 2 alpha should also be maximum. What's the range of sine? -1 to 1. What's the maximum value? 1. So when that is going to be 1 at at theta, at an angle theta equal to, sine is maximum at an angle theta is equal to 90 degrees. So here it's not theta, it is 2 alpha. So 2 alpha should be 90 degrees. So alpha is equal to how much? 45 degrees. If you throw at an angle of 45 degrees, the range will be maximum. This is a simple question, sir. The range of projectile fired at an angle of 50 degrees is 50 meters. If it is fired with the same speed at an angle of 45 degrees, its range will be dash. Without keeping a pen, you can do it. See, at 15 degrees, it is 50 meters. At 45 degrees, just now we have got, if you project with the same velocity at 45 degrees, it will be having the maximum range. That means it will be definitely greater than 50 meters. Now, which option is having more than 50? Answer is 100 meters. Directly you can get. Or if you want to solve. Range formula is u square sine 2 alpha by g. So it's having a range of 50 u square, project at an angle of 30 degrees, 2 into 15 degrees by g. So keep 50 u square by g is equal to sine 30 degrees. What is sine 30? 1 by 2. So u square by g is equal to, send to this side 100. I'm keeping it as it is. The next case, range r dash is equal to same u square, sir, projected at an angle of 45 degrees by g. R dash, I got u square by g is equal to how much? 100 into sine 90 is 1. So what is my new range? 100 meters. Okay. So read the question. This question is also written by me. I only have framed this question. Please, all of you, see here. Please keep reading the question. My favorite opponent is not Pakistan, sir. My favorite opponent is Australia. And my favorite team is 2003 World Cup team. And Ganguly is my favorite player. Read the problem, read the problem. See here, I will solve it, okay? Please see here. In Eden Gardens, India is batting against Australia. The ball is in the hands of McGrath and Ganguly is on strike. Wants to go for maximum. What's the meaning of wants to go for maximum? He's interested to go for a 6, right? If he hits the ball at the maximum possible initial velocity, so he is giving whatever the speed he can give, that velocity he can impact, that he is importing, that is, let us say, some u at an angle. What Ganguly did, he has striked it at an angle. See, nobody will strike at 0 degrees or 90 degrees, right? They will strike at some angle, and he had striked at an angle theta less than 45 degrees with the horizontal. Okay, so with this u and with this theta, with this u and theta, the ball exactly reaches the rope. It will not fall before, it will not fall after. It is exactly falling on the rope. Now, Ponting is standing exactly under the trajectory and in a position where he can catch any ball projected with an angle less than 45 degrees. Just remember this. He can catch any ball projected at an angle less than 45 degrees. That means Ganguly is hitting it at an angle less than 45 degrees. So Ponting can catch it, right? I will show the figure. Just I'll change the slide and show for you so that you can understand it better, but keep this in mind. So Ganguly is striking at an angle less than 45 degrees. If anything is hit at an angle less than 45 degrees, Ponting can catch it. Now he's asking, suggest Ganguly the angle that should be impacted for the same initial velocity. He's not changing the velocity. What are the maximum he can give? He is giving the same velocity, and range also same. He wants that 6, the same range, so that it would go over Ricky. But I don't want Ricky to catch it. When Ricky can catch it, when Ponting can catch it, if it is less than 45. If I strike it above 45, then definitely Ricky cannot catch it, right? So now let us go and see. Please, all of you, see here. Listen, all of you see here. Let us say this is my ground. Let us say Ganguly is here, who is striking it. He has projected the ball. Take this as a 2D, sir. This frame, right? This frame, take it as a frame, right? He is projecting it, he hit the ball so that it is having an initial velocity u. making an angle theta equal to 45 degrees. Now the ball will go like this. The ball will go like this. Now somewhere here, Ricky is, see, very close. Somewhere here, Ricky is there so that he can catch it. He can catch it with his hands. He can catch it, right? So suggest the angle theta. What should be the angle theta? If this is not 45, this is less than 45. This is less than 45 degrees. This theta is less than 45 degrees. So Ricky is able to catch it, take it immediately. If I can impart the angle greater than 45 degrees, then Ricky cannot catch it, right? But Ganguly can give the same angle, and at any cost he wants the ball to go to the, what is this, rope, right? So let us go and see how to do this. Listen to me carefully. It's a bit calculations are involved, so please all of you see here. I have eventually framed this question so that to explain these concepts, listen carefully. What's the formula for maximum height, sir? What's the formula for maximum height? What's the formula for maximum height? H equal to U square sin square theta by 2g. H equal to U square sin square theta by 2g. Let us say the imparted velocity u is a constant, acceleration due to gravity g is a constant. My height, maximum height h max, is only dependent on the theta. Now, what is the range of theta? See, if I project the ball at an angle 0 degrees, it will go in a straight line. If I project the ball at an angle 90 degrees, it will go vertically up and come back. Now, if I want a projectile motion, the angle should be greater than the 0, it should be greater than 0, less than 90. So it can be more than 90 now. Yes, it can be, sir. Whatever is happening on this side, it will happen the same on this side. So because instead of going like this, it will go like this. So I'm not worried about this side. So it is in the range of 0 to 90 degrees. My angle of projection theta, lies in the range. My angle of projection theta lies in the range 0 to 90 degrees. 0 degrees to 90 degrees. So from 0 to sin 90, what's the value of sin theta? What's the value of sin theta? Sin 0 is 0, sin 0 is 0, sin 90 is 1. So that means as theta is increasing from 0 to 90 degrees, my sine value is increasing from, as theta is increasing from 0 to 90 degrees, my sine value is increasing from, listen here. As theta is increasing from 0 degrees to 90 degrees, sine is increasing from what? Same 0 to 1, 0 to 1, right? So I have here sin square theta. Even sin square theta also increases from 0 to 1. That means, what's that? My h max, if it is projected with 0 degrees, so h max will be 0. H max will be 0 at 0. And as theta increases, my maximum height also increases, and maximum value occurs at theta equal to 90 degrees, sin 90, 1. So it will be ranging from so finally my maximum height, it will be ranging from 0 to u square by 2g. So as theta increases, my maximum height also increases. It will never decrease, right? As theta increases, maximum height also will increase from 0 to u square by 2g. So the maximum possible is u square by 2g. Now listen. What happens to my range? Please all of you see here. What's the formula for range? U square sin 2 theta by g. U square sin 2 theta by g. Please all of you see here. Theta is changing from 0 to 90 degrees. but here it's not theta. What is the in sign? What is there in sign? 2 theta. So multiply with 2. 0, 2 theta, 180 degrees. See, theta is in the range of 0 to 90 degrees. 2 theta is in the range of 0 to 180 degrees. Please, all of you see here. Please, all of you see here. What happens to my sine curve? What happens to my sine curve? Sine 0 is 0. Sine 90 is 1. Sine 0 is 0. Sine 90 is 1. And from 90 to 180, what happens? From 90 to 180, what happens? It is again decreasing and coming back to 0. And decreasing and coming back to 0. That means, as theta is changing from 0 to 90, 2 theta changes from 0 to 180. So what happens to my sine 2 theta? It is increasing from 0 to 90, and again it is decreasing from 90 to 180. That means I will divide it into 2 halves. I will divide this into 2 halves. I will divide this into 2 halves. What are the 2 halves? See, first half is when theta is changing from 0 to 45 degrees. 0 to 45 degrees, half, exactly half. 2 theta will change from 0 to 90 degrees. And my sine 2 theta changes from 0 to 1. 0 to 1. It changes from 0 to 1. Now. When second case, when my theta is changing from 0 to 45, 2 theta is from 0 to 90, so sine 2 theta is from 0 to 1. Now when my theta is changing from 45 degrees to 90 degrees, 45 degrees to 90 degrees, when my theta is changing from 45 degrees to 90 degrees, 2 theta will change from 90 to 180 degrees. 90 to 180 degrees. So what happens to my sine 2 theta? Sine 90 is 1, sine 180 is 0. Sine 180 is 0. So what is happening? When theta is changing from 0 to 45, when theta is increasing from 0 to 45, sine 2 theta is increasing from 0 to 1. When theta is changing from 0 to 45, 2 theta, this is the 2 theta. 2 theta is changing from 0 to 90. And sine is increasing from 0 to 1. Sine is increasing from 0 to 1. When theta is increasing from 45 to 90, 2 theta is increasing from 90 to 180, and sine 2 theta is decreasing from 1 to 0. Sine 2 theta is decreasing from 1 to 0. That means in the first half, from 0 to 45, range, as theta increases, angle of projection increases, range increases. And again from 45 to 90, as angle of projection increases, range is decreasing. So from 0 to 45, as you keep on increasing, range will go. We have seen yesterday the maximum range will occur at 45 degrees. At 45 degrees 1, it will go for the maximum. And if you further increase the angle of inclination, it will come inside. I will draw the graph, sir. Just keep this in mind. What is that? As theta is increasing from 0 to 45, sine 2 theta will increase from 0 to 1, and range increases from 0 to, what's the maximum? Sine 45. So sorry, theta is 45. So 2 into 45, 90, sine 91. What is the maximum range? U square by G. So when theta is increasing from 0 to 45 degrees, as it is increasing, what happens to the range? It will also increase from 0 to U square by G. And when it is increasing from 45 degrees to, when theta is increasing from 45 degrees to 90 degrees, 2 theta will increase from 90 to 180. So my range will increase from, it will be in the opposite direction. It will decrease from U square by 2G to 0. It will decrease from U square by 2G to 0. That means for one value of range, every one value of range, let us say this is 0, this is 100. I'll say one example so that you'll understand it better. See here, if suppose this is 0, this is, let us say this value is some 100. I'm just taking some 100. You remember yesterday's problem, 0. At 45 degrees we got 100, and at 15 degrees I got this is how much? 50. At 15 degrees I got this is 50, right? At 15 degrees angle, 15 means here 30 degrees. At 30 degrees, I have a range of some 50 meters. The same 50 meters range is possible. The same 50 meters range is possible with one more angle between this pi by 2 to pi. Between this pi by 2 to pi. Now I want to know if this is at theta equal to 15 degrees. If this is at theta equal to 15 degrees. When again I can get the same 50 meters. When again I can get the same 15 meters with the angle between, what is that? With the angle between what? 45 to 90. 45 to 90. So this is my target to find out right now. Please, all of you, see here. See here. Listen. What is sine pi minus theta, Saran? What is sine pi minus theta? All silver teacups. Pi minus theta, second quadrant, sine is positive. At pi, sine will remain as sine. So, sine theta. I'll just readjust this. See here. I will take 2 common. If I take 2 common, what will happen? 2, pi will become pi by 2. See, if I multiply inside again, 2 will get cancelled. I'm left out with what? I'm left out with 2, right? 2 into pi by 2 minus one small change. One sec. Listen. Sine pi minus, I'll take 2 theta because I'm interested in 2 theta, not theta, right? So what is sine pi minus 2 theta? What is sine pi minus 2 theta? Anything, sir. Sine pi minus 2 theta or sine pi minus theta, whatever it is. Sine pi minus theta is sine theta. Sine pi minus 2 theta is sine 2 theta. Now if I take 2 common, what will happen if I take 2 common? Pi by 2 minus theta. Pi by 2 minus theta. Sine 2 into theta. Now please all of you see here. Either if you have a value theta or pi by 2 minus theta, my sine 2 theta is going to give me the same value because sine pi by 2 minus 2 theta is nothing but sine 2 theta. So either you have here theta or pi by 2 minus theta, you will get the same value. Yesterday's problem, if you remember, at theta equal to 15 degrees, I got, what is sine 2 theta value? Sine 30 degrees, sine 2 theta, that is sine 30. How much is sine 30? 1 by 2. Now for theta and pi by 2 minus theta, what is pi by 2 minus theta? 90 minus 15, that is 75 degrees. So sine 2 theta, that means 2 theta in the sense, sine 2 into 75, sine 150. What is sine 150? Again 1 by 2. So either you project with an angle theta or pi by 2 minus theta, you will get the same range. Theta or pi by 2 minus theta, you will get the same. Please all of you, see here. What is happening? I'm concluding here. If theta, please all of you see here. I'm again rewriting all that we have got. What is happening to my maximum height? As theta is increasing from 0 to 90 degrees, my H max is also increasing from 0 to, how much? U square by 2g, As theta increases, this is increasing, no doubt. In the second case, what's happening to my range? What is happening to range is, it is not varying in terms of theta, it is varying in terms of 2 theta. So I'm dividing into half. When theta is changing from 0 to 45 degrees, sine 2 theta will change from 0 to 2 theta will change from 0 to 90 degrees. So sine 2 theta will change from 0 to 1. So if it is changing from 0 to 1, what will happen to my range? I want space, sir. That's why I'm just writing and erasing. What will happen to my range? Range will increase from 0 to, I just got u square by c. Sine 90 is 1, u square by g. Now, there is the first case. Now, what is happening? If theta is increasing from 45 to 90, degrees, now tell me what happens. My range is not increasing. See, as theta is increasing from 45 to as theta is increasing from 45 to 90, my range is now not increasing from 0 to u square by g. It is decreasing. It is decreasing from 0 to u square by g. From 0 to u square by g. I will explain it here beautifully. See here, all of you. See here, all of you. Let us say this is my ground. Let us say this is my ground. Now we'll go with the same example just now whatever we have done. If suppose with some initial velocity u, I have projected a ball. I have projected a ball with an initial velocity u at an angle 15 degrees. At an angle 15 degrees. At an angle of 15 degrees. From here, at an angle of 15 degrees. It has gone something like this. It has gone something like this. What is the angle of projection? What is the angle of projection? Theta equal to 15 degrees. Theta equal to 15 degrees. Now, if I want the same range, with what angle I have to project? I don't want to go in this path. I have projected with 15. With what angle I have to project so that I will get the same range? Apart from 15 degrees, what is the other angle I have to project so that I will get the same 15 degrees? I have shown you just now. Either you project with theta or pi by 2 minus theta. Either you project with angle theta or pi by 2 minus theta. You will get the same range. See why? Because theta pi by 2 minus theta will get the same. So that means what is pi by 2 minus theta? If theta is 15 degrees, pi by 2 minus theta is 75 degrees. If I project with 75 degrees, what will happen to my range? What will happen to my range? It is going to be the same as 15 degrees. What about maximum height? What about maximum height? See, as theta is increasing from 0 to 90, my maximum height will increase from 0 to u square by 2g. So definitely when compared to 15 degrees, 75 degrees will have a higher height. So how is it going to be? How is it going to be? See here, see here, see here. See, if this is 15 degrees, when you project at 75 degrees, when you project at an angle of theta equal to 75 degrees, the range will be same, but the maximum height will be more. If suppose Ricky is here, if suppose Ricky is standing here, 15 degrees he can catch it, but 75 degrees, he cannot catch. So suggest Ganguly to hit it with an angle not less than 45, greater than 45. So to get the same range, what is the angle with which he has to hit? Not theta, pi by 2 minus theta. What is that? Pi by 2 minus theta. Let me finish for more cases, then we will go back and write it. So instead of 15 degrees, let us say I have gone with 30 degrees. What happens if I go with 30 degrees? See, as you are increasing from 0 to 45, range will increase from 0 to u square by g. So if it is 30 degrees, it will be having a range more than this. For the same initial velocity, it will be having a range more than this. And what about maximum height? If you increase the angle, maximum height will increase. So maximum height will increase, range will increase. So, but 30 is not beyond 75. So the maximum height will be definitely less than this, but greater than 15. So it will be something like this. This is when theta equal to 30 degrees. Now, if I want the same range, what's the other counter angle for this? If this is theta, the same range will come at pi by 2 minus theta. So what will happen? 90 minus 30 degrees, that is 60 degrees. It will give me the same range. But what about maximum height? 60 is greater than 30, but less than 75. So it will have a range. So it will have a maximum height. It will have a maximum height greater than 30 but less than 75. So what is that going to be? This is for a 60 degrees. Next, go with, let us say, some 45 degrees. Let us have gone with 45 degrees. What is 45 degrees? At 45 degrees, 2 theta is 90. So it will be having u square by g, the maximum range. What about height? 45, it is not maximum height. It is at just half. So it will have definitely greater than 30, but less than 60. So it will be somewhere like this. This is the maximum and it is at 45. For 45, what is the counter? 90 minus 45 is 45. There is no counter for it. It is the same, right? If suppose, let us say I have gone with an angle just for one more that, let us say if I go on with an angle, let us say theta equal to 20 degrees. Let us say theta equal to 20 degrees. Now how it will go? It will have a range greater than 15, less than 30, height greater than 15, less than 30. So it will go like this, 20 degrees. Now what's the counter for it? 90 minus 20, that is 70. 70 will have the same range, but it will have a more height. So 70. So 70 will be greater than 60 but less than 75. So how is it going to be? That's how it's going to be. So this is what? 70 degrees. If suppose if I go with, let us say, I don't want to make the diagram clumsy. If I go with, let us say 30 and 45, what will happen? It will go in between this 30 and 45, 40 degrees. And what's the counter for 40 degrees? 90 minus 40, 50 degrees. How will the 50 degrees be? It will be coming like this. Okay, so all of you got this? So what's the answer? What's the answer? So suggest Ganguly to go with an angle pi by 2 minus theta, so that the range will be same but it will go over Reiki. Are you okay? Hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.